So let's work practice problem 14. It's on page 501. Let me read the problem. It says both a 3.3 microfarad and a 6.8 microfarad capacitor are connected across a 15-volt electric potential difference. Which capacitor has a greater charge and which is it? So, and here's how you would draw this if you wanted to draw it out about what's given. Here we have a 15-volt source. It's a battery. And what this means is that everything up here, all the electrons that are actually moving, all the charges that are going to move through the circuit are given a certain amount of energy. 15 joules per coulomb of charge. That's what voltage means. So 15 joules per coulomb. And then down here, it's 0. So 0, 15 volts up here, 0 volts here. So if you hook them up like this, they're both hooked up to a 15-volt source. So this and this capacitor, both capacitors, get the same amount of pressure. You can kind of think of voltage as how hard the charges are being pushed and crammed together on the two capacitors. Well, now to figure out which one has the greater charge, let's take a look at the basic equation for capacitance. Capacitance is equal to the charge on the capacitor divided by the voltage it took to get that much charge on the capacitor. Okay, well, if I want to know how much charge is on the capacitor, and I know the capacitance and I know the voltage across the capacitor, solve for Q, and I get Q equals the capacitance times the voltage across it, or the potential difference across it. Well, look, if voltage is the same, they both have 15 volts, which one, the one that's going to have the most charge is the one with the greatest capacitance. So you can just say because 6.8 microfarads is greater than 3.3 microfarads, therefore more charge on the 6.8 microfarad capacitor. And we've just answered the question. Which capacitor has the greater charge? The one with the greater capacitance if you've got the same voltage. And it says, how much charge does it have? Well, this is pretty easy. Q equals C, which is 6.8 microfarads. And then the voltage across the plates is 15 volts. And so we just have to multiply 6.8 times 50. Now, what about this micro? Do I want to keep the micro? Sure, you can type that in if you want, but what I usually do is this. I'll just say 6.8 times 15. And I get 102. And then, but I got this micro here. So that's times 10 to the negative 6. So it's this times 10 to the negative 6, which is just a micro. And what is a farad times a volt? A farad times a volt. Well, a farad is a coulomb per volt times a volt. Well, the volts will cancel, leaving coulombs, microcoulombs. So the answer is 102 microcoulombs. Now, if you didn't do that, you could say, well, that's 102 times 10 to the negative 6, and you move this over 1, 2, and you could say, well, that's 1.02 times 10 to the negative 4 coulombs, and that answer is also correct. This is just expressed in microcoulombs, and this is just in coulombs, but you need that scientific notation like that. Okay, and so that is how you do practice problem number 14. Are there any questions on this? Make sense? Very good. That is all.